Hello everyone, welcome to another RevGD Rust Learning video blog. In today's video, we will cover the next exercise from Gophercises website, and we will be building a simple URL shortener application. As usual, link to the actual Gophercises website as well as this code implementation will be in the video description below. Before we look at the code, just quickly what we are going to build. So it is not really a detailed, robust, actual URL shortener implementation, but the general idea will be there, how things work, how the mapping happens, and how the redirection will happen. So we will be using sample JSON and XML files to store the mapping, but of course in the actual implementation there will be some kind of a database that will be used. So user will pass that shortened URL, and we will redirect user to the actual URL based on the mapping. So let's get started. So first, let's look at the cargo.toml file. So we are using today, I'll be using the XM web server instead of the Tide that I was using before. Just wanted to give this one a try, see how it works. Tide is good, but I haven't seen a lot of changes or a lot of updates happening on the GitHub. So I'll just give this XM a try this time. So that's our first dependency, and this depends on the hyper and Tokyo as well as tower. So these are related to the XM web server or the application framework, and we are using the YAML Rust to read the YAML file. I believe I might have said JSON, but it is actually YAML file that we will be reading. So next we can look at the main file. So we are using one module, handler, that will actually handle this implementation where we go from the shortened URL to the actual URL. So that will be in the handler. We'll go into that one next. Next thing we are importing is the routing from XM, the get route, and the hash map that we'll be using. So we're starting the web server on port 8080, and we are using Tokyo main, just a asynchronous main method. Next, we are creating in-memory mapping between the shortened URL and the actual URL. So we will have two different ways to map shortened URL. One is in-memory hash map, another one is reading from a YAML structure. So we are not going to use any physical file, but the idea is that if data is coming from a database, so either we are returning the key value mapping, some sort of maybe Redis cache, or we use key value map database, or maybe we have it stored in the YAML, or at least our API returns the data in YAML format. So the first one is just that hash map. So we are building one example is URL short go doc, and it will map to the XM documentation. And next one is YAML go doc that will point to the actual GitHub page for the XM. And then we are creating a handler for this. So this is our um, handler module that we'll see next. That's the module we have created, and we pass the URLs to that one. Next, we are creating a YAML string. So this is standard YAML format. We have path and URL. These are the two attributes, and it's kind of like an array. So then we have another path and URL. And first one is the URL short that will take us to the crate for the YAML that we are using in this application. And the next one is short final that will take us to the GitHub page for the same crate. Then we use the handler again and create the mapping between these paths and URL. Next, we will simply, before we start the XM server, we will create this fallback binding. So if the URL is not found, like one of these URL that are listed above, mapping is not found, then we will show this invalid route message. And then we just simply start the server. And again, we are running on port 8080. And since we already created the route handlers for YAML and the string handler, so two handlers are already created. So we just pass it to the XM server to be served on this port. Next, let's just quickly look at the handler. So in this handler, we are of course using our crate, YAML Rust crate, and we are using the YAML loader from that, and we are using XM for the response and the routing, and also to build the router. So next we have two methods. One is the string handler. So this is for our hash maps. Whatever the hash map we pass into this method, we will create a route between the key of the hash map and the value. So this is how it will know if the incoming request is for the key. It will route it to the URL. So implementation for this part is almost same for the app merge, both in the string handler and the YAML handler. We are using HTTP GET request for the route, and we will redirect it to the redirect URL. That is the value in case of hash map. Once we build these routes that we are iterating over the hash map that is being passed from the main application. So once the routes are built, we just return this app or the route back to the main method. Implementation for Map YAML handler is pretty much the same. First, we are using the YAML loader from YAML Rust to load the data from a string. So we create the string in our main method or the main application. So we load that one through the YAML loader, and then we check first if it is empty or not, and then we try to get the internal YAML representation from the string. So whatever the object was built. So we are because it will return an array or collection, so we just get the first attribute from that, and then this is where it was a little challenging because of how the Rust handles different objects and the whole uh, ownership model that Rust has. So I have to clone this object, otherwise it will give an error that we cannot move the ownership. So we clone it first, then we convert into a vector, and then we just iterate on that vector. Each time we will be getting URL and the path. So URL is the shortened URL and path is the actual path where we want to redirect. So we get the URL and then we are creating a route using this path. That's the key, and the URL that we just pull in here, we just use it to the redirect. And just like the string handler, we just written the method. So now there is one helper method that I've created here to avoid repeating the code for the route. So what this method is doing is it's simply creating a new route for the path and the method that we are using, like the get method um, for the HTTP request and the path. So if you see here on this line, so I'm using this over here route. So I just pass the path, that's the key, and where will it redirect to? So this is the HTTP get method, this is the second parameter, and in this method, in this helper private method, then I use the XM router class, and you instantiate a new instance and create a route based on the path and the router. And then we call the app.merge to merge all these individual routes into the final route and return it back to the application. So if we go back to the main, this is how it was done. So we have YAML and the hash map. Okay, so next we will run. So I already started on port 8080, and what we will do next is just look at some of these URLs. So if I go back and let's try the URL short go doc. If I go back, so let's try localhost. URL short go doc, and we see it redirects us to the crate. Let's try another one. So if we try YAML go docs, it should take us to the GitHub page for the Tokyo or the XM. So localhost, I think it was, let me check again, that one is YAML, YAML, YAML go doc. So that takes us to the GitHub page for the XM. So this was just the hash map. Let's give one more try to the URL short. So URL short should take us to the YAML rest crate URL short. So localhost URL short, and it redirects us to the crate for YAML rest. So that was it for today's video, and all the links will be in the video description. So I will see you guys in the next video.